Let's take a look at next question, question 10. So homework 4.6, and here we have question 10. So question 10 says, let's check the question. What's the question asking? Question 10 says, solve the following differential equation for times the second derivative of y minus y is equal to e to the power x over 2 plus 3. So to solve this differential equation, first we need to form the auxiliary equation, or you can just at the beginning write this in standard form. It doesn't matter. So if you form the auxiliary differential equation for the standard form, you're going to see you have, for example, the second derivative of y minus a fourth y equals to a fourth e to the power x over 2 plus 3. So you get m squared minus a fourth equal to 0. So m becomes plus minus 1 over 2. And as you can see, the complementary solution is c1 e to power a half x plus c2 e to power negative a half x. Well, we have y1, we have y2. Now we need to find the Wronskian. The Wronskian of y1 and y2 is the determinant. Well, here you have e to power x over 2 and a half e to power x over 2. And here you have e to power negative x over 2 or negative a half as the derivative e to power negative x divided by 2. So the multiplication of these two is equal to negative a half minus a half, which is negative a fourth. Well, now that we're done with the Wronskian, we need to find u1 and u2. u1 is equal to integral w1 over w, and w1 is equal to the determinant of 0 and f. This is our f, now that we change everything into standard form. And here you have y2 and the derivative of y2. So let's find this guy first. Here you have here w1, which is equal to 0, a fourth e to power x over 2 plus 3/4, and you have your y2, which is e to power negative a half x, is derivative negative a half e to negative a half x. So this guy becomes 0, and if you just distribute this, you get a fourth plus 3/4 e to negative x divided by 2. So this is our w1. So u1 becomes, I write it down here, I need more space. This guy becomes a fourth plus 3/4 e to power negative x over 2 divided by the Wronskian, which is negative a fourth dx. Well, this guy becomes, if we divide these two, you get negative 1, so you get negative x, and you have minus 3, the integral of e to power negative x over 2 dx. Now by substitution, you get negative x minus 3, and here you have negative 2, so you get 6 e to power negative x over 2. We found u1. This is our u1. Now let us move on and find u2. u2 is the integral of w2 over w, but what is w2? w2 is equal to the determinant. Well, here now we have y1, y prime of 1, 0, and f of x. So this guy becomes y1, which is e to power x over 2, a half e to power x over 2, and 0, and a fourth e to power x over 2 plus 3 over 4. So this determinant is equal to, this is just 0, so we're going to distribute this into parentheses. You have a fourth e to power x plus 3/4 e to power x over 2. So u2 becomes a fourth e to power x is 3/4 e to power x over 2 divided by the Wronskian itself, which is negative a fourth dx. Let us take this integral. This integral becomes, well, here you have negative e to the x, and here you have negative 3. The integral e to the power x over 2 dx, which is negative e to the power x, and you have negative 6 e to the power x divided by 2. So this is our u2. We found u1 and u2, so y sub p, or the particular solution, is u1, y1, so you have negative x e to the power x over 2 plus 6. And the second one is u2, y2. So here you have our u2 times e to the power negative a half x, which gives us minus e to the power x over 2. And here you have minus 6. This is yp. Now that we found the yp, the general solution for this differential equation is yc, which is c1 e to the power a half x plus c2 e to the power negative a half x plus yp. And remember that we can cancel these two out, can simplify this in the nicest form possible. Minus e to the power x over 2 is our particular solution.